Hello everyone. Today I would like to discuss about the Stochastic Frontier Analysis or SFA. To start with, I would like to introduce about the production function. The output is equal the function of the input. For example, in the agriculture, the input is machinery, seed, chemical, and so on. And the output is maybe rice, corn, or so on. Regarding the input and output, I would like to introduce both the productivity and efficiency. The productivity means ratio between the output and input. However, the efficiency is the productivity of the evaluated TMU or maybe farmer, organization, or etc. Uh, compared with the best performance or the highest productivity. To to make easy understand, I give the one example here. There are four TMU ABCD, and this is the quantity of input, and this is the output, and the productivity is ratio between output and input. And here we get the productivity, and the TMUP is the best performance because the highest the productivity. So determine the P become a frontier or reference or benchmark. So the efficiency is the productivity divided by the reference. So for A is here, this is 1, this is 0.5, and this is 0.6. And then this is also example. There are some the farmers and the NPK as input and the production is output. From this example, we have some question. The first question is what kind of the relationship between the input and output here. And the second, is there the inefficiency exists in the production process? Because in here, different productivity and different efficiency. And the third question is which the most efficient farmer? The three questions we can answer using the Stochastic Frontier Analysis or SFA. Until 1960, the most production function analysis was based on the average production function, commonly used ordinary least square or equivalent method. And then the idea include of the frontier production become interesting, and then the idea of frontier was initially implemented as a deterministic frontier by Agner and Chu in 1968. And then Agner, Lovell, and Smith, and Mesham and Van den Broek introduced the stochastic frontier analysis. I give two graph here to easy understand what is the different OLS and SFA. In here, in the OLS, the uh, the production function is taking the average or central tendency, and we just the different the productivity is based on the noise or error. For example, x1, x2, and x3. The difference between the observation and the production function is because the noise. And for SFA, the different performance among PMU is caused by inefficiency and noise. For example, here, this is the observation, this is the observation, and this is the inefficiency, and this is the noise. This is also same. This is noise, and this is the efficiency. So the different performance among PMU is caused by both inefficiency and noise. What is SFA? SFA is method used to measure efficiency in the production cost and revenue function. It spirit inefficiency from random noise in data, and commonly used in economic, finance, and operational research. Before I already share with you about the TEA. What is different TEA and NFS and SFA? The first, TEA is non-parametric method and SFA is parametric method. It means the SFA is concerned about the distribution of the data, but in the TEA, non-parametric is not concerned about the distribution of the data. And also in the SFA is we need to test the hypothesis because we take care about the significant level. But in the TEA we no need to test the hypothesis. And then TEA use the mathematical programming or linear programming model. For example, in like this one, the objective is to minimize the input, the theta, and the constraint is this one. But in the SFA, the parameter is get from the maximum likelihood econometric estimation. This is the formula, maximum likelihood function, like this one. And then the TEA just take care about the efficiency and does not accommodate the noise or error. So the difference among the TMU is just assumed caused by inefficiency. But in the SFA, the SFA spirit between the noise and efficiency. And then the TEA is can accommodate multiple output and multiple input. However, in the SFA, just accommodate single output with multiple input. This is in input. Sorry, I error. And then the TA no need to make the functional form, but in the SFA we need to find the functional form. The advantages of SFA: the first is spirit inefficiency from the measurement error. Second, provide a statistical basis for efficiency estimation, and then allows hypothesis testing on inefficiency effect, and then suitable for final data analysis. But for disadvantages is required strong distributional assumption, and then sensitive to model specification, and the last is computationally intensive. Yes, because I already tried using the Excel to calculate the SFA, but very complex and difficult to solve in the Excel. And then the key concept of SFA, the first is frontier function is represent the maximum possible output for given input. This one, this is the frontier function. And then the efficiency score measure how close a firm is to frontier. The formula is observation divided by frontier line. For example, here the efficiency score is observation production divided by this one, the frontier here. And then here is the efficiency score is here, the observation divided by frontier here. Okay. And then for random error, this one, random error. And from the inefficiency term is here, this one. Okay. And then the general function of form of SFA. This one, the learn output is equal the learn function, the input here is labor, capital, and so on, plus noise and minus the inefficiency. This one, this is same. This is deterministic component. This is noise and this is inefficiency. This one is Cobb-Douglas function. So key here is output. The X x is input, the beta is the estimated parameter or coefficient, and then phi is random noise. In the SFA, we assume the normal distribution. And U is inefficiency term. Therefore, assumption half normal, exponential, truncated normal, and also gamma. And the most popular is half normal and truncated normal. The some common functional form, this is the linear, this is quadruples, this is quadratic, and this normal is quadratic, translog, generalized length, and constant elasticity of substitution. From this, the functional form, the most popular is quadruples and translog. Quadruples is represent the linear function, and the translog is nonlinear function. This is for assumption of distribution for error and inefficiency. This is for error. The error is intrinsically distributed normal random variable with zero mean and variance free. And this is the half normal. UI are independent and intrinsically distributed half normal random variable with zero mean and variance. And this is truncated normal. UI are independent and intrinsically distributed truncated normal random variable with mu, mean, and variance. And this is expositional and gamma. This is different half normal and truncated normal. The half normal is here. The mean in the zero, because the inefficiency only one side, on the positive side, and this is the mean is zero, so we call it the half normal. And in here, the mean is mu here or here or here, so we call it the truncated normal because all is positive and the mean is not zero but greater than zero, so we call it truncated normal. The two assumption is most popular rather than the gamma and exponential. Identification source of inefficiency, because in the production function we just take care about the input and output, but what kind of the factor that influence the inefficiency, and in here is external factor influencing inefficiency. For example, socioeconomic, maybe the gender, maybe in the age, maybe in the experience, maybe in the education, maybe the and so on, and maybe in the technology, the different technology, different management, and maybe in the government policy, the subsidy, and so on. There are two methods to identification the source of inefficiency. The first is one-step procedure. Inefficiency factors run one time simultaneously with stochastic frontier function. The advantage is more efficient, avoid inconsistency, and then provide unbiased estimate of inefficiency effect. And then for disadvantages is this approach will be highly damaging to the degree of freedom. This is the formula. Y is function is x, y, zi, and beta. This is it means the output is equal the function of input, the inefficiency, and the second is two-step procedure. First, run the stochastic frontier function, and then the second, using top-it model, put UI as dependent and inefficiency factor as independent variable. Advantages is it can measure coefficient without any reduction in degree of freedom. But for disadvantages is this approach procedure produce bias estimate then can be severe inconsistency issue. The output is function the the input, and then the result, the efficiency will run using the top model here. And like I mentioned before, but in the parametric we need to test the hypothesis. In here we use the likelihood ratio test of inefficiency, LR test. The formula is minus 2, and then likelihood for null hypothesis or for the restricted model, it means is OLS minus likelihood for the unrestricted model or stochastic frontier. The degree of freedom is equal the number of restrictions in the test. And for half normal, the critical value of the mixed distribution for hypothesis are tabulated in the table 1 of the code and bound. Then the ER test compared with the chi-square table. When LR test is greater than chi-square table, it indicates the inefficiency exists. It is the gamma parameter. The gamma is the percentage, the variance for the inefficiency divided by the total variance in the model. To predict the efficiency, technical efficiency is the observed divided by frontier. This one, this is the observed, this is the inefficiency, main UI, and this is the frontier. So the last is expression on the UI. And some software that can run SFA is there are some packets. For example, Zazam, Frontier 4.1, Lindep, and Stata. And in the next video, in the next future, I will make some video to analyze the SFA using this data. Thank you for watching, and bye bye.